Good day, everyone. I'm Bob Ackerman, the Editor-in-Chief of Signal Magazine, and I'd like to welcome you to our Signal Magazine webinar titled RF Sensor Fusion, Securing Your Indoor Airspace Using RF Device Positioning Sensors. Mobile devices may be the last great cybersecurity frontier. Despite their proliferation, they continue to defy easy security fixes. Growing security threats include unauthorized Wi-Fi, Bluetooth, and cellular devices. As the Internet of Things grows exponentially, security requirements become all the more vital. In today's webinar, which is sponsored by Inpixon, an expert will describe how to establish an indoor security dome that prevents rogue mobile systems from intruding into a wireless realm. This approach can help detect malevolent devices, establish wireless situational awareness, use RF sensors to enforce no-phone zones, and identify persons of interest using sensor fusion. Now, throughout this presentation, webinar attendees are encouraged to submit questions electronically through the Ask a Question box on the webinar console. When our expert is finished with his presentation, he will answer as many questions as time permits during this hour-long session. Today's presenter is John Piccinini, Vice President, Business Development, Inpixon. John's 30 years of work in the security industry include RF detection, indoor positioning, and identity and access management. At Inpixon, he has helped secure some of the most important high-security sites in the world, including government, military, law enforcement, critical infrastructure, and financial institutions. So with that, I'd like to have John Piccinini begin by telling us how to build that indoor wireless security dome. John?
Well, hi, everybody. Thank you, Bob. And thanks, everyone, for joining us today. I do appreciate the time you share with us, and we will be respectful of it and get right into it. Like any other technology, wireless devices and networks can bring significant benefits, but can also pose significant risk. And while we can't totally eliminate that risk, we can work together to manage it, achieving at least a balance between the risks posed and the benefits gained, enabling organizations to embrace the benefits of this new technology, or any new technology, maintain high levels of security while doing so, and comply with the best practices and directives set by governing authorities, in this case through the government. For years, government policy has been to simply ban the use of cell phones and wireless devices in secure facilities. But that attitude and those policies are running up against the reality of the pervasiveness of these devices and the technology, and the benefits that they can bring to the organizations in completing their mission. Some agencies even report that those strict no-device policies hamper their ability to hire people, especially in the technology space, where those types of people can go to the Googles and Facebooks of the world rather than join the government agencies. And the truth is, even if your policies restrict the presence of all devices at all times, you're still at risk of both malicious and inadvertent breaches of those policies. So as agencies move from no device and no wireless anywhere to policies that allow them to be present in some areas and not others, you need some kind of an automated policy enforcer that's location-based, accurate in its positioning, and capable of detecting multi-frequencies, which is what we are. And we'll spend the next 30 minutes or so left describing that and how we've helped others to manage risk in their wireless environments. Now, you've probably all seen these government security directives that have come out. Go back one. From organizations like the DoD, DOE, CNSS, NIST, what is it, 1800-124, publications that say, all right, if you're going to use these kinds of technologies and devices in your space, here's the rules that you need to follow. And these are the kind of rules and guidelines that we followed in developing our systems and approaches to resolving these issues. So if we take a look at the Inpixon Indoor Positioning Analytics, or IPA, for security product, essentially what we do is we detect the presence of RF devices in an area. We look across frequency spreads to Wi-Fi, to Bluetooth, to cellular, and in some cases active RFID tags and transponders. We can then show you the position of those devices on floor plans that you would load into the application that's running, the server that's running our application, and provide that kind of real-time actionable intelligence that location brings. So now you know where devices are, whose they may be if they're known devices. Are they visitors? Are they rogue points? Are they unknown? Are they fixed versus mobile devices? As I said, we can differentiate between known and unknown, or in some cases authorized or non-authorized devices, just by color schemes on the floor plans themselves. One application is to help discover rogue access points or rogue devices operating in your environment. What we see common in the space too is the desire to geofence certain areas. And this is where we can get into that, well, you can have a device here, but you can't have it there concept, where we can zone off certain areas. And the policies can be, well, we don't want to see any wireless in this area, or we want to see only those known devices, government-issued devices perhaps, that are running an MDM client that you can manage in those devices. Or maybe we want to see no devices in those areas. So you can set up multiple zones and have multiple policies applied to those different zones as suit your needs. And then we can also integrate our platform with others. So certainly you can have operators, and many of our customers do, operators sitting in front of a screen that's showing the floor plan and seeing the devices moving around, and we'll take a look at that in a minute. Or we can integrate with on-site command and control platforms. If your security people are sitting in front of a PSIM or an access control or a command and control platform, alarms can be sent to them. Alarms that would indicate devices in areas where they shouldn't be. Those alarms and alerts can be sent to mobile devices that security personnel carry, either by text or email. We can trigger video operations on your video management systems. So it really is designed to work within your security environment and add to all the other things that you're doing, as well as stand alone as a wireless device detection system. Because we see all those frequencies, we can see so many things. And what's happening now in the wireless space, everybody thinks about mobile phones, smartphones, but there are smartwatches, Fitbit type devices, wireless printers, medical devices that are RF enabled. All of those things, wireless cameras, anything that's transmitting in those bands, we'd be able to help you see and position and provide a full situational awareness of your wireless environment, just as you do for your physical security environments and your wired environments. We accomplish this by installing sensors, and here's an image of a sensor, and you can see the sizing as well. And it's, the beige color that smoke detectors and other devices are, so they're designed to fit underneath a drop ceiling. You'll see there's no external antennas or scary looking things that would scare people into thinking they're being irradiated. In fact, the devices are totally passive. So we're not transmitting anything, we're just listening on those frequencies, so we can go into secure areas where you don't want to bring in additional transmitters and emissions and provide a safe, secure environment. And as I said earlier, these devices all look for Wi-Fi, Bluetooth, and cellular activity within the space. I mentioned other devices like medical devices. We had an instance where someone came up to us at an event recently, and he was wearing hearing aids. And he's asked the question if we could see the MAC address of his Bluetooth-enabled hearing aids and whitelist them so people knew that it was him moving around. As it stood then, whenever he went into his workspace, he'd have to shut them off. So yes, certainly we can do that. We can not only see the device and whitelist or label it, we can also show you the connections. So if you want to make sure that they're only connected to each other and not to other Bluetooth devices or other Bluetooth devices that are trying to connect to it, we can monitor that and cause an alarms when we see those kinds of things happening. And this is becoming a bigger issue as more and more of these medical devices enable RF technology to get reports and data out of them. And you'll see more of this. And much of our workspaces or workforce is aging. So we'll see more of this, and we can certainly accommodate tracking those kinds of things. to make sure that only the right things are in the right places. Those sensors connect to a network via Ethernet type cabling. It could be a shared network or a dedicated network, a gap network for this application. They're powered either through power over Ethernet if you have a PoE infrastructure in place, or it can be powered locally if you don't or prefer that. And then they feed their data to a server running our application. The server takes the feed from the sensors, and these sensors are looking at signal strength, essentially. So we trilaterate positions within your environment. So that implies more than one sensor needs to see the device to be able to position it. One sensor might be able to tell you that, yeah, there's RF in the field, but it couldn't tell you where it is. So at least 3 sensors in a grid would need to detect the device. And the software then, through the algorithms we've built, based on relative signal strength, positions it within the floor plans that you've uploaded into our software. Accuracy of the device, depending upon the construction of your facility. If there's a lot of metal, it'll operate maybe differently if it's a wide open office space, but 2 to 5 meters accuracy, again, depending upon the construction and the materials used. The application runs in a Linux environment on a server, and then your operators access it through a browser. So there is no thick client that needs to be installed on client workstations. And of course, it's all password protected. Again, you'll see the 3 major things we do. We detect, we prevent, and I think it's important too to remember that this system will provide you with continuous protection. Unlike a sweep or a handheld detector that might be run occasionally on spots, this system will be looking at the environment 24 hours a day, 7 days a week, 365 days a year. So you don't have to worry that an intrusion happens right after a sweep has been conducted because somebody was scoping that out. We're on all the time. Now, looking at the map, the simulation of the screen, you can see that here's a floor plan. There are some devices marked on the floor plan that the system has seen. The blue devices are devices that we know. These are registered into the system, and you can register them a couple of different ways. You can see it on the map and say, okay, I know this is Joe's cell phone. Right-click and say this is Joe's cell phone. You can import a list of MAC addresses and user names, however you want to identify those devices, or device names if they're fixed wireless devices. And we'll show you later how we can pull that kind of information from other systems as well. So the blue devices that we know for whatever reason. The red devices there are unknown devices. And you'll also see that we're telling you what kind of device it is, whether it's a Bluetooth device, whether it's a wireless device, or if there's a cell phone activity in place, you'll be able to see a little icon that represents a cell phone and its location. A red device, an unknown device, may not be a security problem. So this one here in the upper left-hand side of the screen looks like that might be the lobby, and perhaps that's a visitor waiting in the lobby. And maybe that's not a security issue. However, this red device, this unknown device, has crossed into an area that's been geofenced as secure. And you can see now that it's generated an alert up on our screen that tells you where we've seen the alert and what it is. And this is the kind of information we can share with other systems, again, either by text, email, or sending that message over an API to another system that might be serving as a security monitoring platform for the organization. We can also write all of our events to a syslog output. So if you're running Splunk or something like that, you want to have that overall combined view of your wired and wireless IT and other security applications. We can do that as well. Everything that happens is recorded. So you see here, this is a recording of an event we did at a trade show a year ago. It was at a prison event. And you can see that there are 3 devices that are tracked right now, because we've told the system, look for known Bluetooth devices, and we had 3 tags with us, the 3 employees. And then we went up to the selection pane and said, well, show me now all unknown Bluetooth devices as well. And you can see so many more devices showed up on the screen. And they'll be moving around in real time. We've kind of hit the end of the video here. In an actual environment, as these people moved around, you would see those little indicators, those icons, moving around showing you that position. Later on in this video, if we kept running it, we'd say, well, show us all Wi-Fi as well. And then, the screen gets so cluttered that it's almost hard to see. But we're still tracking every device individually. So if you wanted to go back in time again and play what happened last Thursday night between 3 and 5 o'clock in the morning, you'd be able to do that and say, well, just show me the devices types of devices that I want to see. So if you're doing forensics, it is an easy way to go back in time and recreate your wireless environment at the time. And again, you can see by the color coding what we know and what we don't and what kind of device it is. I'll also point out on this screen, you see these 4 larger circles here. These are the sensors we placed around this environment. Now remember, this was a trade show, and these are kind of the tabletops. It wasn't an accurate drawing, but it was close enough. We made it the day of the event, and the organizer allowed us to put our sensors kind of on the floor in the corner and just hardwire them back to our server. These 2 on the left side, these are about 80 feet apart. These are a little bit longer. These might be 90 to 95 feet. And this is the spacing that we like to see. I talked earlier about installing our sensors in a grid, the greatest degree possible. That would give us the highest degree of accuracy. And we like to see them installed anywhere between 65 to 85 to 90 feet or so on center between the different sensors. That will give us the optimal detection ranges. Now, it's funny, some people will say, well, I've got this conference room. If I put like 6 sensors in there, could I get down to the seat? Actually, if you put too many sensors into a very small area, your accuracy will get worse because now they're all seeing the same signal strength, so they'll all be shown in the center of the room. So we like to either with ourselves or our partners that provide solutions, turnkey solutions to the world, work with you to actually design the optimal sensor placement through floor plans or site visits. And we have that capability, and I'm happy to do that. Now, so how have customers really deployed this? We have customers in the defense, intelligence, diplomatic, law enforcement communities, corrections, for example. But one I'll just talk briefly about is a major combat command headquarters facility in the southeast. Right now, they've got about 300 sensors installed. Just to give you a sense of the size and scope of that facility. And while we don't know everything about it, I can tell you we understand it covers 3 or 4 buildings. It's a little cagey. There's maybe 9 on site they might be considering covering and expanding to. And they've been using the system now for 3 or 4 years. And over the years, they've upgraded. So, for example, we started detecting 2G cellular and then added 3G capability, then 4G, and now LTE. And those upgrades have essentially been firmware downloads to the sensors. People often ask sometimes, well, what about 5G? Well, 5G is coming. There's no set standard yet between the carrier companies. And as those standards evolve, we're very confident in our ability to accommodate 5G. 5G is an extension of LTE, long-term evolution, and we're currently LTE compliant. But when we started talking to this customer, we would get that same comment. Well, we don't allow any wireless devices in our area. And that was the common thread, and we still hear that today. We were at the DOTIS event this week, and some people would tell us that same thing. But the truth is, even if you have that policy, you're subject to breaches. And today, 3 or 4 years later, even after all the knowledge that has been shared about the system in place and no cell phone policies, they still capture 3 to 5 personal devices a week going into their secure areas. And you guys probably know what happens after that. So if someone else sees the device, maybe it's an Apple Watch, and suddenly somebody sees it on the sleeve, or the owner himself self-volunteers. Oh my God, I forgot I brought this in. I'm so sorry. What happens then? The device is confiscated. There's a whole series of very deep and very embarrassing forensics run on the device. The user doesn't have his device for some period of time while that's happening. So there's time and cost and ill will generated when those kinds of things happen. And again, as you know, most of those breaches are inadvertent. I mean, just forgot he had his phone in his pocket or his watch on. But that still represents a threat because there's many ways to take over devices surreptitiously. This has been the common application now, that situational awareness. but many agencies that we're dealing with now run mobile device management platforms. And those of you on the line may be familiar with products like EMC's AirWatch or IBM's Mass 360, MobileIron, BlackBerry. Because many of those have been put in place first, and these allow you to manage what goes on to the devices and vet the applications. They can also be useful in tandem with our system. For example, earlier we put up this slide that showed the different security directives that have come out from different agencies and different authoritative bodies. And they all seem to focus on the mitigation piece described in the center. Disabling the camera when the device is in a secure area, disabling access to cameras, to microphones, to Wi-Fi, to Bluetooth, to browsers, whatever the security policy might be for that area. The problem is all of these directives kind of missed the detection piece. And to be fair, all of the mobile device management platforms say they can have a sense of location, but it's not as accurate as we can be. So if you're trying to protect SCIFs, conference rooms, a certain wing of the building, that might not be, they may not be accurate enough for you to do those kinds of things. They can tell you, yes, it's in the building or it's not, but we can tell you much more precisely where it is in the building. And then through an integration that we have to all of those platforms that I mentioned and can do others, have them trigger an appropriate security policy onto that device. And that integration happens between the software, between the service. So we have an API and they have an API. We send messages in the form that they can accept to their devices when we see a wireless device in an area where it shouldn't belong. So we trigger the location, they trigger the mitigation action. And this reinforces the comment I made earlier that we are totally passive. So the reason we can't directly affect those security policies is that we're not talking back to the device, we're just listening to it, which keeps our platform more secure and lets the MDM platform do what it does best. And several agencies now are looking at accommodating that. This integration brings us a little bit more than just sending messages out to the MDM platform. Earlier I said there's another way to pull user information into the system. Well, we can pull not only all of the users that are registered into the system. So if you're currently running a MobileIron MDM or an IBM Mass 360 MDM, you have a number of devices that are registered and presumably who owns them or some way to identify who owns them, if not directly a name. We can pull that information in and that automatically becomes a known device in our application. Unless you don't want it to be, then you can change its status. We can also pull in all of the security policies that you've established for those zones. So if those already exist, rather than having to recreate them in our system, we'll pull them in. And the cause and effect table in our system says, when you see a device in this zone, trigger this policy. If that policy is already defined in the MDM, we'll just use that. If it's not, you can just define a new one within the MDM. So a really nice bidirectional information that ties location and device to security policy, real time and automatically. We talked about this fusion, integrating RF sensors into other applications. And so I want to switch gears here and talk about one now that we've developed. And in the interest of full disclosure, I'll tell you what you're going to see right now happens in a platform that we run that's cloud-based. Everything we saw before has been on-prem. What we're going to see now has come to us through a cloud provider that we've acquired, essentially. But our goal is to bring the same kind of capability to our on-prem solutions. It's not there yet, so I want to be clear about that, but it is something that we do in the cloud and are working on bringing it on-prem. And that's essentially this fusion to video. Almost everybody has cameras everywhere now. For good reason. They provide very useful information sometimes. But how many times have you been watching the news and you see here's the perpetrator and what you see is the side of somebody's head and he's wearing a hoodie? You don't always get the best imaging. And sometimes it's hard to find the best imaging. So what we do is we can now correlate areas of coverage of our system, areas that those sensors cover, and the zones that you might define, to areas of visual coverage by your camera system through the VMS, the visual management system that's running that the cameras. So cameras in these 3 or 4 cameras in this scene are tuned to the few sensors that might be covering an area that the scene covers visually. And for each frame of video that's captured, we will store all of the devices we see in that scene. So perhaps if an event happens, sorry, my mouse is a little jumpy here. If we see a device that you want to further, a scene you want to further investigate, you can freeze the frame. You'll see the image, and if the image is great and you can pass this out to the police or your security people and say, watch out for that guy, maybe that's all you need to do. However, if you can't, or if you want to learn more about that individual, you'll see all of the devices we captured in the area at the time that image was captured. Now, there might be 10 or 12 or 20 devices in the area, but now you can start backtracking the video into scenes where you've seen that same person of interest. And we'll start narrowing down. So now maybe there was 20 devices in the first scene, and there's 15 devices in the second scene, but only 3 appear in both. And now we see a third scene, but only 1 appear at all of those scenes. So now we can correlate that MAC address of that device that he's carrying to that person. The integration captures a timeline of all the times we've seen that device. So now you can go back and say, all right, show me the scene at this time. Show me the scene when we've seen the device here. Show me when we've seen it here. To get the best image of that person for evidentiary purposes. But now you can also get kind of a history of the behavior of that person. Like in a retail event, it might be, well, he was casing the store for 3 weeks before he actually pulled off the robbery. And when he was casing the store, he didn't bother to wear his disguise, but when he pulled off the robbery, that's when he put the hood on and the sunglasses, but now we know what he really looks like. Same thing if there's a security breach in a government facility. Perhaps this is a way to understand how many times this person was in an area where he shouldn't be or times where he shouldn't be, and capturing both the device history and the video history. What's nice is chances are the cameras are already in place, so we can leverage the cameras. And there's a handful of major video management systems that this integration currently exists with. It is, again, an SDK API type integration, so if somebody has a product that we currently don't integrate, we're certainly willing to take a look at what that product is and see if it's integratable to give the same kind of capability. In addition to that, looking back forensically, we can also provide proactive alerting. So now we know the device, we can watch that device, and that's a function in our system, our application, to watch that device, and whenever it comes back into the facility, you can be alerted to the presence of that device in the facility and start taking appropriate actions. It could be alert the security teams, be more alert to this guy, follow him around, activate cameras to start recording in higher resolution whenever I see this device in a scene. Anything that might be pertinent as a security response to this individual being on scene. And we often think of this being a bad guy. In some cases, it could be the director of the organization, somebody at a high level of VIP that you want to make sure gets special treatment. So you can use that alerting for the same kind of capability. And again, it correlates video to the devices. And I think what's interesting for many government agencies is that it can also work across multiple buildings and locations. Most agencies have multiple facilities, and there might be somebody that either has a grudge or an employee that's doing something nefarious across multiple buildings. We can watch that person the same way across multiple buildings by the device he's generally carrying. And then once we see that device come back, we can alert then as needed to the appropriate people, again, by sending email messages, text messages. We can embed that person's image in those text and messages. You say, hey, this is the guy we're looking for. We just saw him at the lobby. So again, in respect of time, let's start to wrap up, and we'll open up the questions. I think the key takeaways here are that wireless is pervasive and can be a mission enabler. I mean, so many things now are equipped with wireless capabilities. Yesterday at the DOTIS event, one of the agencies we were talking to, was describing how they were on a frantic search for some wireless emissions that they were getting. And it turns out it was a wireless printer that somebody installed that had wireless capabilities. So they did that search, and whatever triggered it, they didn't even know that it was there. We would let you know that it's there, so you'd see it, all the time as part of a situational awareness capability. There are many of these directives that have been published, again, from DoD, from DOE, from CNSS, from NIST. Best practice is to follow those, and we'll help you do that. We'll help you enforce the policies that the agencies and yourself have published by deploying that effective, accurate, and continuous detection system that Inpixon has been doing since 2005. And then by integrating with mobile device management, or as they now like to be called, universal endpoint management systems. But they'll also address wired desktops and the whole range of online devices. Our ability to integrate with those platforms really gives you full detection and full control of all the wireless devices in your area. That essentially helps you not just balance, but tip the scales in your favor. To enjoy the benefits of wireless, to stop resisting like a wave that's probably impenetrable at this point, and use this technology to your benefit, just like you've done in the past with other technologies. So with that, Bob, we might want to open up to any questions that have been asked.
Okay, John. Well, thank you. And again, everyone, I'd like to remind you to hit the Ask a Question box. If you'd like to ask some questions, we've got some in the queue, but we also have a lot of time. So let me begin with the ones we have already asked through the Ask a Question box. First one was one I wondered, does it work outdoor?
Well, that's a good question, Bob.
Not mine.
Okay. Wireless signals don't necessarily stop at walls. So even a system that's designed to cover an indoor area can see devices that are just outside the perimeter. Now that might be a good thing because you might have somebody sitting outside with a wireless access point trying to trap people to connect to their rogue access point, trying to connect to his access point. You might want to know that. So the first part to that answer is yes, even the indoor devices, if they're near the outdoor perimeter, can see outside. And there are ways, though, to go into the system and trim it, optimize it, I should say. So maybe you set a very high, I want to see devices that give me a very high level of assurance of its location, which may weed out some of the off-distance outdoor devices. We also have customers that take our sensors and put them outside to get more outside coverage. But keep in mind, they work best in a grid. So if you're trying to see devices that are far away from your building, outside of that 80 to 90 feet or so, you might need to have sensors 80 to 90 feet outside your building as well to properly position them in their location, in your outside area. If all you want to know is there's something outside, either your sensors inside the building or depending upon the nature of the building and positioning, we can put some on the outer walls as well and get you more of that outside area. So the question is, yeah, it could. Well, the answer is.
Yeah, got it. That does bring up a question I'd like to ask, very loosely related. You mentioned 5G earlier. And it's coming, and it's going to bring huge bandwidth advantages. But the 5G hubs will have a shorter range. Will that affect the architecture of your system in terms of finding RF devices inside and outside?
They will indeed have shorter range. I think, though, if you think about that 1,000 square foot coverage per sensor or 80 to 90 feet separation, I don't think we'll be bumping against the limits of 5G range. Now, a couple things 5G might bring is it might put less reliance on traditional Wi-Fi networks. So our ability to discover cellular transactions, as many systems don't, could become more important as people move off Wi-Fi to 5G. And the other thing is, because of that range restriction, it's not just range, it's also building penetration that is a concern with 5G. one of the concepts on 5G deployments is to deploy these micro cells within large buildings. It might be an office building or a government agency that owns their own building or a shopping mall or whatever that might have a little micro cell in the building that collects all the data from the phones that are in the building and then retransmits out to the main stations. So, range and coverage are things that are going to be handled by either the design of our sensor system or the 5G deployment as it goes in. But some of that is still to be determined.
Right. Understood.
Mm-hmm.
I'm just being theoretical here, but theoretical
Sure.
is how we all have to think ahead at times. Next question is very practical, on the spot. With this being a cloud sharing product, what security is in place to prevent all of the data from being compromised on the cloud or through data exfiltration?
Sure. I will say that most of the applications we've done, or actually all of the applications we've done in the traditional security and especially the government security space have used our on-premise solution. So not necessarily cloud-based. I showed that video cloud environment simply because that's a feature that we'll be introducing at some point in time to our on-prem solution as well. It exists only in the cloud version right now, but I wanted to give you a taste of what we can do with this application. And the reason I wanted to do that, and one of the points I should have made, is that just like GPS, when the Navy put those satellites in space whenever they did years ago, I'm sure they didn't expect that the primary users of that would be for us to find our way to a new restaurant or customer location. But once the infrastructure was in place, more and more applications developed. And we see the same thing happening here with indoor positioning. Once that infrastructure is in place, the first element might be those security applications. The second might be monitoring healthcare devices or asset tracking, by using Wi-Fi or Bluetooth sensors. We're looking at adding things like wayfinding and, of course, this video application. So the application does not have to be cloud-based. In fact, almost all of them are still on-prem based. Our cloud application is more geared towards the retail customers that want to track the movement of shoppers throughout a facility, their paths, their dwell times, things like that. But they're not as concerned about individual identification, but more following the crowd and less security concerned. Did that answer the question from whoever asked it? It might be Eric.
We can hope.
Mm-hmm. Okay.
So,
if not, you can type in again. Mm-hmm.
Okay, sounds good. Next question is very basic. What are system requirements? What type of server do I need?
The application itself runs in a Linux environment. It's CentOS or CentOS OS. Depending upon, it'll scale with the size of the system. So our minimum spec says, you should have a Intel 4-core machine, 32 gigabytes of RAM, maybe a terabyte of disk space. But if you grow that system, as that one customer we talked about did, to a few hundred sensors, we might need to add more RAM or distribute some of the processing across multiple servers. So, it's not a supercomputer. It's a server. It can run in a VM environment, but we're looking at typical Linux type environment with reasonable specs in terms of RAM and memory and disk space.
Okay. Another question, basic one. Does it scale? Can it handle multiple buildings and floors?
Yeah, we've built it to scale. As I said, you might need to scale your server up as we add more and more sensors. If you think about the environment the sensors are operating in, it's seeing a lot of devices and constantly transmitting information back to the servers. So the more devices that are in an area and the more sensors you have, the more we might have to beef up that server. But it's designed just to allow you to add sensors as needed to cover your areas. We can support multiple buildings with remote servers that kind of serve as data collection points for that building, and then can transmit it to the main server that's collecting all the data throughout the enterprise. So yes, it does scale. I don't know of an upper limit that's been reached in the real world or theoretically yet, but it is designed to scale and grow with you and your needs.
Okay. Next question. Someone wants to know which groups or areas of USG have installations.
Mm-hmm. As a good partner, we try not to reveal names of customers in these open kind of forums, but I can tell you that probably our largest single component discipline would be Department of Defense. Beyond that, energy, diplomatic, and intelligence community missions are the ones that typically have deployed these kinds of systems. We can provide like kind of one-to-one references, interagency. Hey, I don't like to name names and specific sites over open forums, and I hope our customer base respects that.
Okay, understood. Next one is something that also struck me. Someone has asked, what is the minimum space between sensors to receive an accurate fixed location?
Yeah, and it is a good question again, because like I say, we don't want to get them too close together, which is kind of counterintuitive sometimes. But we like to see them at least 60 feet apart, center to center, and that would be kind of on the X and Y plane. We've seen them as far as, and if you saw the video that I had up, I don't know when you joined, whoever asked the question, as far as 90 to 95 feet apart. But within that range is what we like to see, with that maybe 60 to 80 being the optimal. And it also depends. It depends on what you're optimizing for. Some customers are more concerned about Wi-Fi, some Bluetooth. If the real concern is Bluetooth, we have schools, for example, that will give Bluetooth tags to the kids in the event of a shooter or other emergency. Well, there we'll put them a little closer together than if we're really looking for Wi-Fi or cell type environments. So that's 60 to 80 feet, and then a little bit more can be stretched. Again, depending upon the construction of the facility. If there's a big steel staircase in the middle of the facility, or a skiff, or in a prison, 3-foot thick walls with rebar, we might need to get a little bit closer together to compensate for that. But no less than 60 feet.
Got it. There are two follow-ups. First one is directly related. What is the minimum number of sensors necessary to get a good fix?
Once the system's in place, at least 3 sensors need to see the device to be able to position it, because we do a trilateration process. That's a slightly different answer to the question, which was what's the minimum number of sensors? The smallest system size would be 4 sensors, even though 3 need to see. We always have one sensor that serves as a channel discovery sensor for the cellular and LTE bands, because they'll change those. So once the system's in place, that sensor will also serve as a positioning sensor, but it's also doing something extra. So it's constantly, periodically looking for new frequencies that might be appearing in the scene. So the smallest system we would deploy would be 4 sensors, but at least 3 sensors need to see a device to position it properly.
Okay, the second follow-up is, will you be able to get MAC addresses for LTE devices?
That's a good question. What we see in a cell phone transaction, and let me be clear too, to show it as a cell transaction, the cell device needs to be active. So a quiescent cell phone is probably not going to show up on the map. Yeah, it pings the tower occasionally, but it's not predictable. It's not as quick as people would think, or as frequent. And it's so fast that the positioning information would be useless, because we'd see it for a millisecond and then the device is somewhere else. So what we see on a cell transaction, what we show on the map, is I have a transmission here. And you'll see a little indication of a cell phone, and again, it would be normally a red device. If that device also has Wi-Fi and Bluetooth on, we can then see, or Bluetooth on, we can then see the MAC address. But just for a pure cell transaction, no, we'll see where it is, but we won't be able to give you the user information. And part of that is, the FCC blocks us from pulling certain pieces of information off a cell transaction. and off the phone.
Well, another person has a related question, which I'll ask now. What about devices that randomize their MAC address while not connected to an access point? How do you track those?
Yeah, God bless Apple, huh? We kind of randomize the MAC address to begin with at the device level, again, for privacy issues. And if that person, I'll put my email address up later, sends me that question by an email, I'll get him a more technical answer. But I know that certain things in location services either randomize or do not randomize that MAC address. So it is an issue for us. We're constantly working to overcome it, and they're constantly working to defeat tracking systems. So it's kind of a cat and mouse game. And again, maybe by email I can answer questions related to that with a real technical authority.
Okay. Next question, we're getting back to basics. How long does it take to set up a system of, let's say, 8 nodes or so?
Mm-hmm. The installation itself is fairly simple. The device has a bracket, again, that can mount it to a drop ceiling or a wall. We've had some, we've gone into industrial type buildings where there is no drop ceiling and the ceiling is maybe 20 feet high. So then we've had people construct posts, that hang from the ceiling and then carry the sensor on the bottom end of it. But in a typical installation in office type facilities, fairly simple. Anybody that can install a smoke detector or a camera, these kinds of people, our integration partners that do that, some government agencies do it themselves, can install these. If you're running PoE, it's just a Cat5 or a Cat6 cable to the nearest switch. So they can be up and running pretty quickly depending upon the resource that we're using to do the installation. Is it the customer's own technical people, or is it an integrator that they'd like us to recommend that can do that work for them? And what is the access to the facility? Is it restricted? Can they work in the daytime? You want to have it done in the evening so employees aren't there while it's going in. But it's fairly simple, and if you've installed a video system, it's probably as simple as that.
Okay. One question. Do you have GSA or CHES pricing?
We don't ourselves. We have partners that carry GSA schedules, and some are under the SOUP contract. So we leave that to our partners for a number of reasons. And CHES I'm not familiar with. We do have partners that have GSA pricing.
Okay. Another question, is the product NIAP approved and or on any APL or RPL lists?
At this point, we have just completed an assessment for NIAP and have that in-house now and are looking to see what it takes to be compliant and what we have to do to the system to make it so. Up until this point, it's gone on dedicated networks that are air-gapped to minimize the concern about certification. But we recognize that it's something that needs to be done, and like I say, we're in process of developing an application to a lab for NIAP. But we've had the assessment done, and we just got that information back in place. So no, but coming.
Okay.
And we have gotten ETO. I will say we have gotten ETOs at various sites, and I know that they're moving away from that concept, but we have been able to work in these areas.
Well, here's a related question. Do you carry any DoD certifications like JITC or UC APL?
Not yet.
In the works. Okay. Another question, at what levels does the product work with MDMs? What kind of information or alert triggers are in effect?
It's essentially an API call that we send a location indicator to the MDM, that just links to the security policy they've established in the MDM platform. Is that, I don't know how else to describe it. I mean, it's an API integration.
Mm-hmm.
And I see the next question, is it published or open? It's published internally. We don't publish it, you know, on the internet or our website or anything like that. But if a customer has a requirement and it kind of makes sense, we can share the API information with them. But it's not on the open market.
Okay. Next question is, can your system detect malware running on particular devices?
No, that gets into, you know, full-scale WIDS type applications. We really don't do that. We just detect the presence and locate it.
The device is there, but you don't know what it's carrying.
Right. We don't look into the headers or anything else that the phone is doing. We just pick up its presence and plot its location.
Okay, got it. Next question. Do the sensors require constant power, or can they be battery powered?
That's an interesting question. A little bit of both. Obviously, they need to be powered to work. We do have a configuration of the system, like a rapid deployment kit. We call it a portable system kit. That has, and this was designed for our corrections customers, because they tend, think about a prison. The installation in a prison is just so difficult, particularly if it's an old style prison, you know, with the big thick walls and the long rows of cells. It just gets too expensive for them. So they'll take this rapid deployment kit while the prisoners are out in the yard, set these sensors up in a housing unit, and then at night when the prisoners are back lighting up their cell phones, now they can see what cells are active. Those devices come with a battery that'll power it for 8 to 10 hours or so, and can be equipped with a wireless mesh backhaul. We typically don't do that in fixed installations. Number one, because a lot of our customers don't want us generating any RF. And number two, because there's so much data in the larger system, we would overwhelm the wireless backhaul. But for that unique application, that portable rapid deployment kit, there is a configure, and it comes in, you know, Pelican cases that are shippable with tripods and everything you need to set up equipment on a temporary basis. Now, some agencies have taken these and used it as their people have traveled. So maybe top-level people are going and they're going to be in a hotel somewhere having conferences. Maybe they want to set a system up like that, so they'll take that environment. So there are configurations that are battery-powered, but you know, in most cases, fixed installations are power over Ethernet or locally powered.
Okay. What is the lead time or availability?
Mm-hmm. As a manufacturer, obviously, we're concerned about the product itself, the sensors and the associated software. Lead time is fairly quick, weeks. For example, if someone gave us an order today, it would ship before the end of the government fiscal year. So anybody with year-end money looking for a place to put it, this could be one. But I would say, in most cases, 2 to 4 weeks is reasonable. Delivery. Now, installation, you know, again, is going to depend on who's installing it and what the physical conditions are like when we're facing installation. But delivery from the manufacturer is within 2 to 4 weeks.
Okay. I'd like to step in and ask a question of my own.
Mm-hmm.
With all the new capabilities coming up in mobile communications, it's going to be a very interesting time in the coming years. How do you have plans set for your system to evolve to meet these new capabilities?
That's you know, the price of being in technology space. We're constantly, you know, we have a full engineering team that's global in its disbursement. Some are focused purely on working with carriers. This is how we're looking at some of the 5G developments that are coming, the carriers and the people that make the equipment that the carriers use as their infrastructure. Looking at technologies, again, like Bluetooth and RFID, things like what's on the horizon next, ultra wideband. So we're constantly looking at, where is the RF environment going, and what is it we would need to track. And to stay in business, we have to stay on top of these things. But we have, engineering teams and product management teams that put out a roadmap that look at what's coming down the road, what customers are asking us to do, and how we can best get there.
So you're working,
and I'll say I'll just say the last thing too. Our presence in Palo Alto and the Silicon Valley also helps, because not only are some of our partners, but some of our customers are the highest tech companies you can think of. The FANGs of the world that keep us on our toes through their demands and by sharing information back and forth on what they're doing down the road. I'm sorry, I cut you off.
That's okay. What I was saying is you're basically working with the folks who are leading this revolution to stay on top of what comes next so you can respond accordingly.
It's absolutely what we need to do. And just another point along those lines, I said earlier, we've been at this since about 2005, and many of our government customers might know the name AirPatrol, which was what the company was before Inpixon bought it. And but the AirPatrol product is still alive and well, and as I said, customers that have older AirPatrol sensors, most of them can be upgraded to current firmware. And if it's old enough that it can't be, we have some interesting programs to make upgrades happen.
Okay, well, on that note, that concludes our Signal Magazine webinar for today. I want to thank our expert for his presentation, and thanks to all of you for joining us. You can continue to link to the archived version of this webinar, along with previous Signal webinars, on the Signal Magazine website at www.afcea.org/signal/webinar. Thank you again, and have a good day.